Hello, this is Aparna presenting the first video on Introduction to Queue Data Structure. The topics to be covered in this video are Introduction to Queue Data Structure and queue operations. The learning objectives of watching this video are to get familiarized to the queue data structure and implement queue operations. So let us start with discussing what is a queue. In general, a queue is a line of people or a line of vehicles waiting for some service. So here in this image we can see people waiting for service, and here we can see vehicles waiting for service in the gas station. Now let us see what is a queue as a data structure. Queue is a linear data structure. It is an ordered collection of homogeneous elements. In a queue, insertion and deletion follows first in first out scheme. That is, the element that is inserted first is the element to be deleted first. We can see that here in this image. So there are 4 items inserted into the queue. So this is the first item inserted into the queue first. Then this is the last item inserted into the queue. The first item to be deleted from the queue is item 1. So in this way, queue is a first in first out data structure. Now let us see what are the various queue operations. The possible queue operations are enqueue. Enqueue is for inserting an element into the queue. So enqueue operation can be implemented by using a function that returns void and takes an object as its argument. The second operation is dequeue, which is for deleting an element from the queue. The return type of dequeue is object and it takes no arguments. The third operation is to return front element from the queue. The return type of the function is object and it takes no arguments. The next operation is to check whether the queue is empty or not. So the return type is boolean, and even this function takes no arguments. And the last operation is full. So the purpose of this function is to see if the queue is full. So the return type of this function is boolean and it also takes no arguments. So let us look at the array implementation of queue operations. So starting with the global declaration of global variables, max size defines the maximum size of queue. Since the queue is to be implemented by using array, we have to specify the maximum size for a queue. And queue of max size declares the queue. Front is a variable that points to the front element in the queue, and rear is a variable that points to the last element in the queue. Initially, front and rear must be initialized with -1. So this case happens whenever queue is empty. So starting with the first operation, is empty. This is the implementation. So whenever front equal to -1 or rear equal to -1, then means that queue is empty. So here we are checking for the condition. If front equal to -1 or rear equal to -1, then return true. Otherwise return false. The second operation is to check if Q is full. The function is full function. Whenever Q is full, then rare points to the last element in the Q. So already we have declared maximum size of the Q to be max size, and since we are implementing Q by means of array, the starting index of the array is at 0 and the last index could be max size minus 1. So whenever rare becomes equal to max size minus 1, it means that the Q has sufficient number of elements in it and it is full. So in that case, this function returns true, otherwise the function returns false. Another operation is get front. So this simply returns the front element in the Q. So whenever Q is empty, then Q of front returns nothing. The next operation is NQ operation. This is for inserting an element into the queue from rare. So in order to insert a new element into the queue, first we must ensure that there is room for new element in the queue. So we have to check for is full. So if is full returns true, means the queue is full. So simply print queue is full and stop. Otherwise, element can be inserted into the queue. While inserting first element into the queue, we have to increment front, and for the remaining elements only rare is to be incremented so as to point to the current location where new element is to be placed in the queue. Q of plus plus rare equal to element will increment rare first and new element is inserted into the position pointed by rare. DQ function is for deleting the element from front. So in order to delete an element from the queue, first of all queue should have at least one element in it. So we have to check for the condition is empty is true or not. If is empty is true means Q is empty. So simply print Q is empty and return an error code minus 100. Otherwise, if Q has at least one element, return the element pointed by front. So after returning the front element, the first element, front must be incremented so as to point to the next element in the queue. Thank you for patient listening. If you have any questions, contact me through my mail ID and mobile number. Thank you.